Now we are going to start the another topic, that is equilibrium of force system. Equilibrium of force system. See, equilibrium means it is a condition where the sum of all the forces equal to zero. Equilibrium is a condition where the sum of or the resultant of all the forces will be equal to zero. So I'll write that. Equilibrium is a condition equilibrium is the condition where the resultant of the force system will be equal to zero, where the resultant of force system is 0. So simply we can say equilibrium means sum of all the forces equal to 0. Now let us write the equilibrium equations for the force system. So as I said, the resultant of force system equal to 0, it means sum of all the forces equal to 0. So this is the one equilibrium equation. Now when the sum of forces equal to 0, the sum of moments will also be 0 because moment equal to force into distance. Now these are the two equations comes under equilibrium equations. Now let's take a planar system. Let's take a planar system. So planar system means it is a two-dimensional system where there are two axes, that is x and y. So the equilibrium equations we can write sigma fx equal to 0, then sigma fy equal to 0. Now similarly we can also write sum of all the moments about x-axis equal to 0, then sum of all the moments about y-axis equal to 0. So these are the equilibrium equations for the planar system. Now let us write equilibrium equations for the spatial system. So spatial system means it is a three-dimensional system, we know that. The equilibrium equations for the spatial system are sigma fx 0 means sum of all the forces about x-axis equal to 0, then sum of all the forces about y-axis 0, then sum of all the forces about z-axis equal to 0. Now the corresponding moments will also be 0 because sum of force equal to 0. Now let us write the equilibrium equations for the moment, that is sigma mx equal to 0 means sum of all the moments about x-axis equal to 0, then sum of all the moments about y-axis 0, then the third equation about z-axis, sum of all the moments about z-axis 0. So these are called the equilibrium equations. So these are the for planar system. Now these are the equilibrium equations for spatial system. Equilibrium equations for the spatial system. So this is about the equilibrium of force system. Now let us discuss some theorem which is related to the equilibrium. Now let us discuss the Lami's theorem which we will be using in equilibrium condition. So Lami's theorem can be explained with the help of three forces. Let us say, let F1, F2, F3 are the concurrent forces So F1, F2, F3 are the concurrent forces, and the angle between F1 and F2, F2 and F3, F1 and F3, let us say alpha, beta, gamma. So now the force F1 is acting like this, let us say, because when I say concurrent forces, all the forces must meet at a common point. So let us see that. Let this is F2 and let this force as a F3. So these three forces are the concurrent forces. Concurrent forces means the line of action. So this line is known as line of action of this force. So line of action of all the three forces is a point. Or simply we can say the forces, that is F1, F2, F3, if all three forces are meeting at a common point, we can say those forces as a concurrent forces. Now let's take the angle between F1 and F2 as alpha, then F2, F3 angle, let us say beta, and the angle between F1 and F3 is, let us say, gamma. So alpha, beta, gamma are the angles between forces as shown in the diagram. Now according to this Lami's theorem, so there is an equation, that is there is a formula given by Lami's. So according to Lami's theorem, force F1 divided by sine, so this is F1 I have written. Now force F1 divided by angle between remaining two forces, means angle between F2 and F3, that is beta. So I will write beta. So which is equal to force F2 divided by sine of, so F2 means I will close F2. Now what are the remaining forces? F1 and F3. So what is the angle between F1 and F3? It is gamma. So I will write gamma is equal to the force F3 by sine. Now I will close F3. Now the remaining forces are F1, F2. So what is the angle between F1 and F2? That is alpha. The angle between remaining two forces means F3 divided by angle between remaining two forces, means I close this F3. The remaining forces are F1 and F2. The angle between these two is a alpha. So I write sine alpha. So this is the theorem we call as a Lami's theorem. So this is known as Lami's theorem. In which cases we can use this Lami's theorem? So let us see that. Means conditions to apply Lami's theorem. Conditions to apply Lami's theorem. Number 1. So totally there are 3 conditions. The first condition is all 3 forces must be concurrent forces. All 3 forces, that is F1, F2, F3, must be concurrent forces. This is the first condition. Now the second condition is out of 3 angles, that is alpha, beta, gamma, minimum 2 angles must be known. Minimum 2 angles must be known. The last condition is out of these 3 forces, that is F1 and F2, F3, one force must be known. So out of 3 forces, one force must be known. So these are the 3 conditions where we can apply this Lami's theorem. One is all 3 forces must be concurrent forces. Then out of 3 angles, minimum 2 angles must be known. The third condition is out of 3 forces, one force must be known. So if any problem satisfies these 3 conditions, we can apply Lami's theorem to calculate remaining 2 forces because one force is given.